Hello everyone, welcome back to the channel. I know this has been a long time since I've posted anything, but here I am back, and we are going to be solving this question, which was from CodeChef Starters 93 contest. It's called Break Free. So, since I gave the contest after a very long time, so I was not able to solve it during the contest, but now here I am upsolving it. So let's read the problem statement first. We are given a chef who has an array A of length n, and B denotes the array obtained by removing any non-empty subset of indices from the array A. So we have to remove any subset which is non-empty from the array A, and the removal is said to be good if the sum of the subarray A, subarray B, which is obtained after removing that subset, should be divisible by 2 for all pairs of indices. That means this is not the sum of the subarray B, it is the sum of all the subarrays of B, and that includes the subarray with size 1 also, because I is less than equal to j, which denotes that we can also have one element in the subarray also. So we have to find the number of good removals. Since the answer can be huge, we can modulo it by 10 to the power 9 plus 7. And yeah, so sum of an empty array is 0, which is divisible by 2. So if all elements are also removed from the array, then sum of the empty array is 0, which is also divisible by 2. So we are thus given that we can also remove all elements of the array. So let's look at an example. So we are given an array A. The contents of the array are 1, 2, 3. So since we can remove any subset either of size 1 or size 2, so I would be choosing to remove this subarray of 1 and 3. Why? Because since in the remaining part of the array, which is B, I suppose, B should be even. Why am I saying so? Because suppose if I remove only the subset 1, then remaining array A, which would be accumulated in B, would be 2, 3. So if 1 is removed, then B should be 2, 3, and we are given that every subarray of B should have an even sum. So let's suppose this is a subarray which is 3 only. It is clearly odd, and if we take an subarray of size 2, then also the sum is odd, which is 5. So we can't remove only one odd number from here. And similarly, if suppose you intend to remove 2 from here, let's suppose 2 is removed, then what would be the array B now? Array B would now be equal to, array B would then be 1, 3. And if array B is 1, 3, then one of the subarrays of B is 3, which has a sum odd. Another subarray of B is 1, which is also odd. So this makes it pretty clear that from array A we have to remove all of the odd numbers. So odd numbers must not be present in array B. Thus each element of B must be odd. Okay. So this was the case. Since each element of B needs to be even, so we can choose to remove the subarray 1, 3 can be choose to be removed from this array A, and if this is moved, then we are left with in array 2, which is clearly all subarrays of it are even, and we can also choose to remove all the elements of array A. We can also choose to remove all the elements of array A, which would give us an empty B. And since it was given in the question that we can have an empty B whose sum is 0, which is divisible by 2, so this is also an answer. So answer for this test case is 2. And if we look at the problem statement, then yeah, answer for the second test case is 2. So I hope you understood what the problem was trying to say, and let's see how we would arrive at the solution now. Suppose we were given an array A, even, this is odd, this is even, this is odd, this is even, and this is even. Okay, 4 elements of the array A are even and 2 are odd. Clearly from the previous example, this needs to be removed, this odd number needs to be removed, all odd numbers need to be removed. So what we are left with now? We are left with only even numbers, and to include it in subarray or not, it would be totally our choice. Either we can take it or remove it. We can take this or remove it. We can either take this or remove it. We can take this or remove it. What would be the answer for this case? Clearly it would be 2 to the power number of even numbers in the array. Yes, but there's one exception to this answer also. Like in the case where we have all numbers even, if we apply the same approach there, that suppose this is removed or taken, either this is taken or this is removed, this is taken or this is removed. So if all of them are taken only, then we would be getting the same subarray B as array A, which would violate our condition, because in our question, if you look at the question, it was clearly stated that we have to remove any non-empty subset, and in our case, if we take all the elements of array A and not remove anyone, then the array which was removed would be an empty subset. So this should be removed from the answer. So thus we have an edge case if even is equal to n, which is the size of the array, then our answer should be two to the power even minus this one case where all the elements are taken. Okay, so now let's look at the code of the problem now. I hope you understood this. If you didn't, then you can ask me in comment section too. The code of the problem. In our main section code, I have taken t test cases and I've solved this question here. We have taken n, the size of array A, and then we have taken the array A. We have maintain the count of even numbers. If we encounter an even number, we would increase the count of even number, and then clearly we have taken this. The answer would be power of 2 to the power even, which was clearly an answer. And if this statement results to be true, then it would return 1. That is, all elements of array A are even. Thus, 1 would be removed from this answer. And if this statement proves to be false, then we would be returned 0 from it, and answer would remain as it is. And let's look also the code of the power function. If you are learning comparative programming, I know how to calculate power of a number from this method. If you don't, you can see it. We have to take an unsigned long result equal to 1, and what we have to do, if we have to manipulate the bits of the number and return the result. And also we are taking care of the mod. See, this is the mod, and this is 10 to the power 9 plus 7. So here only the modulo which we had to do of 10 to the power 9 plus 7 is already taken care of in this function. So, and thanks for watching. I hope you understood the problem. If you didn't, then you can now ask me in the comment section. And thanks for watching.